This is worksheet 12 and 13. And I'm hoping you've all seen the sine and cosine graphs before, but we're going to talk about where they come from for just a second. So the sine function, I think I already have this open. The sine function, let's see. This is not the best, but the sine function graphs the x value. So, no, it graphs the y value, right? On a good day, sine is y, cosine is x. Okay, let's try the y value. When you're right at, oh, maybe this is the video that I thought I couldn't find. Okay, but the sound isn't working. Sorry. Yep, no idea. I'm just doomed, guys. I think it's this room. Anybody have any ideas? Huh? All right. I'm just going to stop this one and we're going to go to this one and talk about the sine graph. Okay. So the sine is graphing the red segments because it's the y value. So do you see how it's going too fast for my eyes, but do you see how the red starts slow, gets longer, then it goes negative? Okay. It's graphing those red pieces. So if I went back here and I did them in red, when I started here, as I rotate around, there is no up and down, right? So that's 0. As I rotate around the unit circle to here, the height gets a little bit longer. If I rotate to here, it gets longer. 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 Now, if that is a unit circle, what is the maximum length it hits? 1. Everybody okay? 1 unit, because it's unit circle means the radius is 1. Okay, now if I attempted to draw all those little red, move them over here, do you see that they were getting longer and longer until they hit 1? I didn't do a very good job, but does that seem like I moved them over there? Okay. Now what happens in this quadrant to the height as I move my point around the circle this way? Yep, the height is getting shorter and shorter. Everybody see that? Until it's back to nothing. Okay. And then what happens to the height when we get down this way? It starts getting longer again, but its y value is what? Getting negative. Does everybody see that? Until it gets down to -1. So if I copied those same little segments over here, whoops, that one got really long really fast. Okay. I'm not doing a very good job because they should not be making a straight line. And then as we go over into this quadrant, they're doing the same exact thing, except they're getting a little bit what? Shorter, okay? Okay, mine is not good at all because it looks like a V and it's not supposed to be a V, and sometimes I'm better at drawing this than others, but it should be that it's like a fourth of a circle, a fourth of a circle, a fourth of a circle, and a fourth of a circle. Okay, now even my circles look horrible. Okay, try to make those match the circle a little better. Yeah, just laugh at me. Okay, so that's what a sine graph looks like. It is a wave. It repeats over and over, so it would continue to go this way, and it would continue to do that again. That is called a periodic function when it repeats, okay? So the sine graph graphs the vertical change y as theta moves around the unit circle. All right, if I had graphed it going this way, can you tell if it's an even or odd function? Do you remember that from semester 1? Can you fold it across the y-axis? Right, this bump would not match up to a bump over here, okay? But if you rotated 180, will it look the same? Let me just do this. If I did this, and I took and spun that 180, would it be the same? I don't know if it'll let me do it. Does that look the same? Okay. So do you remember what that means when it rotates 180? It is an odd function, okay? It has origin symmetry. Now, in the coming lessons, we're going to talk about moving it up and down or shifting it left and right. So it won't always have origin symmetry, but the initial function does. I guess we'll go on and do cosine. If I go to one of these websites, I already have one open, scroll down. So this is the sine, okay? I thought, here we go. Cosine, do you see how it's measuring this way? The blue lines are measuring left to right instead of up and down this time, okay? So it makes more sense, I think, when I talk about it on here, but what's happening, I'll do it in blue as well. If I measure the x value over to here, what is that x value, guys? It's a unit circle, so it's 1, right? So we transfer that guy over here, that's 1. Then as I rotate up to here, my x is still pretty long, right? As I rotate up to here, the x is getting a little bit shorter. And then x gets a little bit shorter, a little bit shorter, a little bit shorter, until I don't have any x, yes? Okay, again, that's supposed to be making a fourth of a circle. I am not good at this. Okay. Now, what happens to x's as I have to go to the left a little bit? X is getting longer, but what does x do as I go left? It's negative, right? So as I'm going left, the x's are getting longer, and it's getting negative. So that's why they translate like this, because they're going left. And now what happens down here? They're still going left, but they're getting what this time? Shorter. Okay, still going left, but getting shorter. Oh. And then when we get down to this 3 pi over 2 or 270, they start to go longer again, but this time they're going what? To the right, so they're positive. Everybody with me? Ooh, that one almost looks round. Okay. We always graph these in terms of radians, not degrees. Now, if I were to continue this pattern, can you tell if it would be even or odd? If I graph just a little bit of it again here, can you tell what that is? Does that have symmetry with the y-axis here, if I drew it well? So it would be even, it would have y-axis symmetry. That will be true if we shift it up and down, right? It'll stay y-axis symmetry, but if we shift it left and right, it will change. All right. I don't know if I have this one open, just to show you a different, nope, that's the same one, right? We were just doing, all right. Let's talk just a little bit more about this. If we go back even to the sine one, if all the way around took us to here, guys, what is that ordered pair? When we go all the way around, we have traveled 2 pi, and we wound up back at 0. So what was halfway to 2 pi? 1 pi? Everybody with me? And halfway to pi? Somebody nice and loud? Pi over 2. And what is the coordinate at pi over 2? We're up here, so it's pi over 2, 1. Is everybody getting that? This purple dot up here? I should have put just a line here, a tick mark, not a. And then this one was 0, 0. Going to the right, anybody know what falls between 1 pi and 2 pi? You look at your unit circle. Do you know the label that's halfway in between there? 3 pi over 2. So this ordered pair down here is 3 pi over 2, comma what? -1. Okay, all of those same values are on the cosine graph. They're just shifted over a little bit. Does everybody get that? Okay, if we start here at 0 for an x coordinate, we end up all the way around later. This is 2 pi, okay? But this time at 0, we're up at 1. At 2 pi, we're back up at 1. So what is that point halfway in between those? It's pi, but can anybody give me the ordered pair? Pi -1. And halfway in between 0 and pi is pi over 2, 0. And over here is 3 pi over 2. Okay, so they're exactly the same graph, except one is shifted a little bit from the other, okay? So you're going to need to memorize those basic shapes and the fact that sine, okay, sine starts at the midline because we're going to shift that line up and down. It's normally the origin, okay, normally the origin, but it starts at the midline and goes up and then down, right? This one starts at the what? The maximum of the function. Can I use that word? It starts at the max and goes down. And this one starts at the midline and goes up and down. Okay? That is the difference between sine and cosine, and you need to memorize the difference between those. Notice that the cosine function is simply a horizontal translation of the sine function. In other words, it's shifted left or right. It doesn't matter because it repeats, okay? Let me do this real fast. If I do this in red and I grab it with my cursor, do you see that I can translate that to the left and it'll become a cosine? with the max at the y-axis, or I can shift it to the right. And then if I repeated it, it would be an upside down. If I kept going far enough, okay, it would match the cosine graph. That one's a little hard to tell because I didn't do a very good job. All right. Therefore, sine and cosine are called sinusoidal functions. I just need you to hear that when you see this word, it doesn't just mean sine, it means sine or cosine. Either sine or cosine are lumped together and called sinusoidal. That's not a big deal until we do modeling later. All right, amplitude. The definition of amplitude is half the distance between the max and the min, or half the height of the wave. Here is where you can write that in your notes. Amplitude is half the distance between the max and the min. Okay? And if you wanted to write, it's also half the height of a wave. And they're saying half as in from the very top to the very bottom, it's halfway. So it's how far up above the midline or how far below the midline. So if we have a midline, okay, it's how far above is an amplitude or how far below. This is super important. The amplitude is always positive because it is a distance. The amplitude always comes out positive, okay? When you have a function, a vertical shift, remember how this went last semester? This meant it was a vertical stretch or shrink, okay? So putting a number out here changes it vertically, which changes what we call the amplitude. So we're not going to call it necessarily a vertical stretch or shrink anymore. We're going to now call it amplitude. All right, I'm going to swing back to this slide, and it says the periods of sine and cosine function. Well, the definition of period, okay, is the length it takes to repeat one cycle. Anywhere that I start on this, as long as I get back to there, that is the distance of one period. So here it says the length of a cycle can start at any point on the graph. So if I have a function that's doing this, and it's supposed to look symmetric, I could start and measure from here until it goes all the way through the cycle and it finishes here. This would be a period. But I could also maybe start at the maximum and measure to the next maximum, and that would be a period. You can start anywhere, okay? It means I started here, I did one full cycle, and I'm back here. How long did that take me? Now, the relationship between the function and the period is really weird, but we know this. Do you remember this? Remember that reciprocal relationship garbage? If we put a 2 in here, it actually compressed it. Okay? So the same is happening now. When you see cosine of bx, you have to take the normal period of 2 pi and divide it by b. We're not going to deal with negative b's, so don't worry about negatives in there, okay? But to find a new period, you're going to take 2 pi divided by whatever the b value is in the function. And that comes from bx. So it could be sine or cosine here. So we're starting right out talking about stretching and shrinking both horizontally and vertically. That's giving you a headache. This slide talks about, and we'll just fill it in on the next one. I think I won't talk too much about this one. I think you have this, right? Is this 1 right here? So to do a sine, I'm going to write up here y equals, I wish I could use their letters. Did I put this somewhere? Here. Oh, it's off on the right. It's right here. Just kidding. You don't have it, but it's up on my slide. I'll write it bigger for you, but it says the parent function is f of x or y equals sine x. And again, it only goes up, it starts at the origin, that's the big deal, and it only goes up to 1, and it finishes the whole cycle by pi. So it goes halfway up, halfway back, halfway down to -1, and halfway back. And it would continue to do this. I didn't hit, that should be through there. But it will do this infinitely. Okay, so the domain left to right is all real numbers. Does that make sense, guys? Because it's a function that continues doing that pattern. Can you tell me what the bottom and top numbers were, though? Do you remember? Yep. So bottom to top would be -1 to 1. Now the x-intercepts, well, this one starts at 0, 0. But where does it cross again? Do you remember what this label was? It goes pi, 2 pi, 3 pi, 4 pi. We can't list them all. So they would say you could add or subtract, because you could also go this way, pi, multiples of pi. Do you remember we talked about that very briefly one day before, said n, where n is an integer? And an integer is like -2, -1, 0, 1, 2, da, da, da. So you can't add a half a pi and expect to hit an x-intercept. You got to add a whole pi. All right, so the y-intercept is just 0, 0. It has no asymptotes. The amplitude, remember, max minus min divided by 2, or the distance above and below. So this distance up from the midline is just 1. And how long did it take before it cycled through here all the way until it was done doing both the up branch and the down branch? Was a distance of 2 pi. All right. And the transformations, now some of the worksheets will have a little bit different. I like their letters. They use sine, B, and then they go ahead and use the H and K that we're used to. And I would suggest we should have an extra set of parentheses here. So H is a shift which way? Anybody know? Left or right, yes? Okay, and K is a shift up or down. We're not going to worry about those yet. The H shifts in this class in Trig are very tricky. Okay, amplitude is the absolute value of A must be positive. Okay, the period is 2 pi divided by B, and B is never going to be negative for me, so you don't have to worry about that one. The horizontal shifts are going to be plus or minus H, and I'm plus or minus K. And since we're not really doing those today, I'm not going to write all this crazy left, right, up, down. We'll do that later, okay? All right, cosine is very, very similar, so I'm going to go a little quicker through cosine. The cosine, though, starts at the maximum and ends up back at 2 pi at the maximum. Halfway there, it's at its minimum. So it's looking like that. Let's see, minimum, maximum crosses at pi over 2. All right, so it's y equals cosine of x. Okay, they used f of x. I'm too lazy to go back and change it now. Domain is all real numbers. Bottom to top is still -1 to 1. Can anybody help me though? This time, what is that point where it crossed the x at? The first positive x-intercept was not at 0, 0. It was where? This is pi, so this would be pi over 2. So it has an x-intercept at pi over 2. And then can you tell me how long until it would have another one here? Yeah, half a period later it crosses again. So we're adding multiples of pi. Not going to ask you that on a quiz, I don't think. The y-intercept, it crossed y at 0, 1. It has no asymptotes. Amplitude, guys, how far above and below that midline does it go? Still just 1, and the period is still 2 pi. So it's a cosine b x minus h plus k. The amplitude is still a. It still has to be positive. If they give us a negative when we state the amplitude, what would a negative do, guys? If you put a negative on the outside of a function, do you remember what that does? Yeah, it flips it upside down. The negative has nothing to do with actual amplitude. The period is still 2 pi over b, and I'm just going to say plus or minus h and plus or minus k, and we'll worry about those later. All right, anybody need more time? All right, I'm going to skip. Do you have this? It's at the bottom of that page, okay? Just make a note here that the notes up above used H instead of C, and the notes up above used K instead of D, okay? That's it. And so you might want to circle this one too. We're not going to do that yet, but the midline could be called y equals D or y equals K. We're not doing those shifts yet. Okay, it says using radians. This is what you are required to do when you graph these. Find the amplitude and period for each function, then graph labeling at least 5 ordered pairs called the quarter points. And they have to be exact values, okay? So your homework is actually to do some delta math. Let me just talk you through. I won't even graph this because I don't think you have to do these in delta math tonight, but does everybody see that the b here would be 1/3? Okay. If b is 1/3, the period is 2 pi divided by 1/3. Do you remember dividing fractions means you have to flip it over? So the period becomes 6 pi. So this sine graph is stretched all the way out. It doesn't, whoa, I didn't do that right. Doesn't finish until 6 pi. So actually by 3 pi, it's done half of its cycle. Okay. Anything in front affects the amplitude. So this stretches up to 4 and down to -4. All right, so try this delta math. You will have more time next week, but it's called Trig graphing 1. Thanks. Have a great weekend, guys. I'm jealous you get 4 days off. 5, 1, 2, 3, 4, 4? Yeah, thanks.